Greetings, welcome back to ECD Laboratory, second semester Diploma in Electronics and Communication. In this video, I'm going to explain about experiment number 3, how we are going to perform in our laboratory and what we are going to do in this experiment. I'm going to explain you how to perform in our laboratory. See, in session number 3 theory, I'm explained about the active component, 3 active component. One is the diode, Zener diode, another is a BJT, how it looks and what are the different type and what applications and terminology and package, everything we have discussed in a theory part. In this part, we're going to identify the terminology and we have to test whether it is working or not. Whatever the device we will going to test, active component, one is diode, PN junction diode, there is a Zener diode, another is a BJT, both PNP and NPN we need to test using the multimeter. So this I'm going to explain in this video. So first thing, identification of the terminal, it's a very easy, this covered in theory session also. Same thing will going to replicate it, but it's very easy. Identify terminals of the diode. See, these are all the different diodes is available in market. If you carefully observe the diode, the one end of the diode have a silver color mark, the color band. This you can see, this is a color band. This color band indicates this is a cathode point. So this is about cathode, this 3R cathode. And in this one there is a black color band, this is also cathode. If one point is identified, one terminal is identified cathode, then the other point is a anode. See, these are all the anode. See, coming to this type of device, there is a symbol represented on the printed on the body of this diode. See, here it's a symbol. With the help of symbol we can say it's anode and this is about cathode. So this way we can identify this terminology of this diode. And there is a one special diode they call this BY127. In BY127 there is a one end having a curve, the another end is a flat. The flat end is says anode, the curve end is says cathode. So this is another way. There is a one more kind of Zener diode is available. That Zener diode has a dot, red dot indicates it's a cathode, another will be a blue dot indicates anode. So this way we can identify the terminology. With this terminology, as per the symbol, we can use it in our circuit diagram. So this is the first identification of the terminology of the diode is over. Now we need to check whether it's working or not. See, the working of diode can be done with the help of the multimeter, having two concept or two procedure. One procedure is multimeter have a diode test mode. In the multimeter, if you see the multimeter, there is a diode symbol on that one. See, here you can see with help of this symbol, in this mode we can test, that is called diode test mode. There is another concept called as a resistance mode. Either using diode test mode or resistor mode, we can test the whether the diode is working or not. We can conclude that. This you have to go and do it in your experiment. How we are going to do that, I am going to explain. It's very simple. See, first take a multimeter and switch on the multimeter and connect the LEDs. One is a red color, is in a V ohm mode. Another is a common socket. That is a black color, is in a common socket. And check continuity. If you touch both the LED of this multimeter and put this in a continuity, it should be buzzer and it shows zero resistance. Then it's indicate that the multimeter is working properly. Then dial this knob, this dial you should turn and place it in a diode mode. This is the first procedure. You place it in a diode mode and take the diode. The diode has a two terminal, another is anode and cathode. The red should be placed at the anode and black color should be placed at the cathode. See, this says there is a forward bias. See, whenever the diode is connected with a positive anode and negative cathode, the diode starts conduct. Whenever there is a start conduct, there is a value displayed on the reading. This is example 0.573, and this reading will be varies as per the multimeter and the diode. It's not a constant. Assume that it is not a constant. The value varies from 0.5 to 0.8 if it is silicon diode. Whatever diode is manufactured based upon the silicon, the value varies from 0.5 to 0.8. If it is germanium diode, it varies from the 0.2 to 0.3 watt. Based on this concept, if it is a forward bias, if you get this value, the diode is good condition. We can say diode is good condition. It works in forward bias. And in a reverse bias, how we can say reverse bias? Anode is connected here, red is connected to negative and black is connected to cathode. Just interchange the terminology and you should get the OL. OL means it's a infinite range, that's out of range. That indicates that is a infinite resistance. If it is infinite resistance, means we can say diode is good condition. Means it's a forward bias working it shows 0.7, and in a reverse bias it shows the out of range. This is the indication of the good diode. And there are some diode, if you have issues, we can say in forward bias, if it is open, we can say OL. OL indicates it forward biased. If it says ON, it's a diode bad condition. And if it is in reverse bias, if the current flows, then we can say it's a short circuit. There is a drop. This is the indication of the bad diode. See, with the help of this procedure, we can test the diode using diode test mode in the multimeter, and here we will get the value of 0.5 to 0.8 for the silicon diode, and germanium diode 0.2 to 0.3 volt. This you have to do it. You have to test for both the forward bias as well as reverse bias. Coming to second procedure, that is called resistance mode. If the multimeter doesn't have a diode indication or diode test, then you can use this ohm meter. With the help of ohm meter, we can measure the forward resistance and a reverse resistance. By this concept, we can identify whether it's a good diode or bad diode. Simply place this ohm meter mode, multimeter, place the dial in a ohm meter node and connect the black into a common and red into a V and ohm mode. And first thing, you should identify the forward resistance. For forward resistance, you have to connect the red color, that is positive, to anode, and a negative black to cathode. You will get some value, that is a forward resistance. It should be lower value, it's from less than 1000, that is a forward bias resistance. If you get some value, then it indicates it's a working. And you just interchange, that is called reverse resistance. Anode is connected to negative and cathode is connected to positive. You will get the OL indicates it's a good diode. If failed in this both the cases, then you can say it's a bad diode. Means if it is a lesser resistance in a reverse bias, that means that if shows some reading in a reverse bias, you can say it's a reverse block, it is not working, there is a break in the junction. We can conclude that this diode is having a damage. This way, with the help of this two mode, we can able to identify the diode is working or not. And you should remember this is the concept we use for Zener diode as well as a transistor also. You should be very much practiced about this procedure. And coming to Zener diode, same, it is also diode. It is made up of it is meant only to work in a reverse bias condition. That's why we have to check for both the forward bias as well as reverse bias. So this is a identification, the terminology we can identify. This is anode and this is a cathode. How we can identify? There is a black color tab. This black color tab indicates cathode, and this is a symbol and arrow mark, and there is a Z color symbol. This is a black indicates the cathode, and this is anode, and this is a package, and this is a through hole package, and this is about surface mount. This is about Zener diode. And the Zener diode can be tested in a two-way. One is using the external voltage sources. The external voltage sources, why we are using this, we have to use external voltage sources we are using to test the external voltage sources we are using to test the breakdown, Zener breakdown voltage of the diode. So this is one important test one has to do this, but as per the syllabus, we need to test the Zener diode with the help of the multimeter. This is the additional input I am giving it for a further enhancement of your knowledge. See, you can do this test in a laboratory to test the breakdown, Zener breakdown voltage of the Zener diode. See, why we have to do means, whenever the manufacturer, always whenever if they give any Zener diode, the manufacturer says this Zener diode has a 9 volt, or some diode may have a 12 volt. See, this way they have done manufacturing, in the sense this diode has to break down, reverse breakdown has to happen across the 9 voltage only. Means if this breakdown happens less than 9 volt, then diode is wrong. That is a very important point we need to identify. For this purpose, we are going to do step 1 procedure using a power supply. We are going to, and multimeter, we will check the reverse breakdown voltage. And if it is the good diode, means always has to breakdown occur only when it reaches to the breakdown voltage mentioned in the data sheet. If they mention 9 volt, means the breakdown occurs as to 9 volt, or more than 9 volt as to breakdown. If it happens less than, then we can say diode is a wrong one. So this is a one mode. The another mode is the ohm meter mode. We can use either of this mode and we can test. This is a one good way to test the Zener breakdown voltage. See here, this is the combination. You have to connect regulated power supply 0 to 30 volt. You have to take regulated power supply with one small resistor. You can take it 1 kilo ohm resistor, and this is a reverse, you have to connect it in a reverse bias. Reverse bias means the positive has to connect it to cathode, and negative has to connect it in anode. See, and you should put the voltmeter, ohm meter, you turn the knob, rotate the knob and place it in a DC voltmeter. It should be measured in a DC voltmeter and place it in the range of 30 voltage, and you keep on increase from 0 to 30 voltage. You assume that this Zener breakdown voltage is mentioned 9 volt. Manufacturer has given is a 9 volt. Means if you give 0 to 8 voltage, there is a voltage is increase 0 to 8 voltage. Whenever you give 9 voltage, there is a breakdown uppers and 9 voltage. After the 9 voltage, if you give 10 voltage, it should show 9 only. And if you keep on increasing the voltage 11, 12, 13 like that, if you keep on increasing the voltage 30 voltage, the Zener diode has to give only 9 voltage. So this is called Zener breakdown voltage, and it is a working. Like that, if they have mentioned 9 voltage, and if the input voltage, that is RPS, regulated power supply, is increases, and if Zener voltage is also increases, means it's a bad diode. That you should know it. So this way the Zener diode conducts in a reverse bias condition, and only if it is applied reverse voltage is a more than the Zener breakdown voltage. Zener breakdown voltage means 9 volt, means it start conduction after the 9 volt. That's why it's a Zener breakdown voltage. This is a one way. In this way, the meter must be such that we increase the variable supply. If you keep on increasing the variable supply, meter output should increase until the breakdown voltage, that is a 9 volt. After the 9 voltage, it should be constant. Behind this point, the constant value of the voltage irrespective of increasing the input voltage. If it is so, the Zener diode is healthy. If this condition meets, it's healthy. If we apply 12 volt for the Zener diode for the 9 volt breakdown voltage, the battery should shows the with the resistor, it should shows the 9 volt. So this is the healthy Zener diode. And there is another mode we can test the diode, Zener diode, using the ohm meter. Ohm meter as a two concept. You can place the multimeter in a ohm meter mode, that is a resistance, and we need to measure both the resistance. One is anode to cathode. This is the anode to cathode. We can say it's a forward resistance. The forward resistance means positive is to connect to anode and negative is to cathode. The diode should read moderately low resistance, means some low resistance less than 1000 it should display low resistance value, then it is a good condition in forward direction. And from cathode to anode, that is a reverse direction. This is a cathode and this is anode. Cathode has to connect at positive and anode also connected to negative. That diode should read a much higher resistance. The multimeter may even indicate OL, that is a reverse direction. Reverse direction means out of range. Then the circuit is since the resistance is so high, it's a huge value, then it should shows the out of range, then it is a working condition. Either of this way we have to check. Forward resistance is a low resistance, reverse resistance is a high resistance, then we can say Zener diode is working. But there is a two more concept. We can say open diode and short diode. See, what is meant by the open diode? There is a difficulties, means the diode has been, the junction diode has become open. If it is open, means in a forward direction also it is a OL reading, and reverse direction also it is give OL, then we can say diode is open diode. Then short diode, when it will happen, if it is forward diode is given low resistance value, and when resistance reverse bias also give low resistance value, we can say it's a short diode. See, like this we can identify the troubles in a Zener diode. And coming to transistor, there are different transistors available in market. I have shown here some of the samples in a picture. You can say with the number also, and each transistor has a 3 terminal, and the size of the transistor is keep on increasing as per the power rating. And each transistor have a heat sink. Why? Because means they have dissipated the heat to the external environment. They have to make it cool. That's why they are using as a heat sink as a metal in the body cases. And each transistor have a predefined terminal, that is emitter, base and collector, that can be identified with this concept. There is a flat surface keep in front of you, in front of the faces. From the left to right, it's a emitter, base and collector. Whether it's a PNPN or NPN, it's the same concept. And this is a symbol represented. It's a PNPN symbol, NPN symbol. N represent the arrow mark towards the emitter outside the circle, and if it is inside the circle, it's a PNPN. And there is another type of transistor like a cylindrical. Here is there a notch. From this notch we can say emitter, base and collector. So these are the terminology, and these are all the different transistor package available in market. And you can say this is a package, how it will be look. I have explained in theory also. You can go through the data sheet, and this transistor can be tested using three mode. One is built-in transistor testing, diode testing, and ohmmeter testing. See, what is mean by built-in transistor? Some of the multimeter have a concept like a built-in HFE value. The HFE value is called as a gain. See, there is a point like a EBC, emitter base collector. There is a NPN and PNPN. There is a total 6 volts in this one yellow color. You can say this is called built-in transistor test. You take a NPN or PNPN. If it is a NPN, you have to place it NPN section. If it is a PNPN, you have to place NPN. But connecting, you should be take very carefully. You have to connect emitter to emitter, base to base, and collector point on the multimeter built-in socket, and keep this knob at the HFE mode. Here the indication HFE mode. HFE mode means it's a gain mode, and switch on the multimeter. It will display some value. This is called gain of the transistor, also called as an HFE value. It is available in the data sheet. If you open the data sheet and if you see the HFE value, if both the HFE values matches or nearly approximately gives the reading, then we can say it is a good transistor. This is the one way we can test the transistor. The other way is to test the transistor using diode mode. Why we are going to use the transistor with the diode means the transistor is made up of a 3 layer. We can say either we PNP or NPN. See, NPN. See, if you see here, we have a 2 junction. There is a junction 1 and junction 2. Here also junction 1 and junction 2. It is nothing but a diode. 2 diode connected in such a fashion, it becomes a transistor. That's why we use the diode test mode, same as we explained at the beginning of the presentation. Here, this is a diode 1. If you consider NPN, see here NPN. So this is a base and this is emitter and this is a collector. So this is a base, this is emitter, and this is collector. So this PN, it's a 1 diode. You can say this is a diode 1. So this is diode 1 and this is diode 2. This is a P and N. This is a diode 2. See, we can use this 2 point. Take the multimeter and put it in a diode mode, and take the positive and place it at the base and negative at the emitter. It should use the value of 0.7 or 0.6 to 0.8. It is a good diode. And same thing, you have to reverse it. It should be open. Then it's a base emitter junction is good. And take the base to collector junction diode and place it positive and negative here. It should be give small value. It's a 0.6 to 0.8 voltage. This is good. Forward bias and reverse it, and if it is open low, then we can say the transistor is good. Like that, it's a reverse direction for a PNPN. This is the way we have to do for a test mode. See here explained, taken a emitter base collector transistor. There is a forward biasing test for the base emitter junction. First they will do base emitter junction. This is a positive is connected to base and negative is connected to emitter. This is what we call NPN transistor. See, it should give 0.7. It is a good, and they have done reverse bias of base emitter junction. It's a open level. The base emitter junction is good, and they take base collector junction. Base is a positive and collector is a negative. Base is a positive, collector is a negative, and see this is a 0.7. It's a good, and reverse they have interchange the direction, and it's a open loop. It's a good. So this way they can test the emitter base in a diode mode. And if it is a faulty diode, this is the condition. If it is a emitter base junction, if it is a positive and negative, it gives open. This means the base collector junction has become open. That's why it gives the open point. This is the wrong one. And same, if they interchange the base collector junction, it gives 0 value. It's reversing. This is the one example of a faulty thing. And there is another mode. We can use the ohmmeter mode. Ohmmeter mode means likewise what we have done diode testing. The diode testing can be done with the multimeter diode test mode as well as a ohmmeter mode. Same thing, we can use it here in transistor also. The good transistor should have a base to emitter junction as a forward bias and collector base to collector junction as a reverse bias. So this is the way we use to configure while building the circuit for a amplifier or the switch. See, for that we have to take a ohmmeter and place it in a ohm mode, and positive is place it in base and negative in a emitter. So this is a NPN transistor as per the symbol. and it shows the low resistance for a base to emitter junction forward bias. This is good. And take the reverse, means it's a reverse biased across the collector to base also. This is first they measure the forward and they measure the reverse also. This is a positive, it's a NPN. P is a positive, N is a negative. They will measure the forward. If it is a low, it is good, and same thing they have to interchange and they have to measure the reverse also. It gives the larger value, it's a open value. Then we can say the transistor is good. Base emitter junction is forward bias, while the collector base junction is a reverse bias. The forward bias base emitter junction should low resistance. It should give the low resistance, and the reverse biased based collector base junction, this collector base junction should give the much higher resistance or open OL reading. This says about the transistor is working. This way we can do the transistor testing, and you can same procedure apply to the PNPN, but the polarity is different. You need to go through with the symbol. Thank you.